In this lesson, we're going to learn how to graph linear inequalities that include horizontal and vertical lines. Let's begin with an example. Graph the inequality y is less than or equal to 4. We begin with our graph where we're going to graph the line y equals 4, which is a horizontal line passing through the y-axis at 4. We use a solid line because our inequality has an equal to symbol, and now we simply need to decide where to shade. Our inequality is y is less than or equal to 4, so we look at the y-axis and identify where the y values are less than or equal to 4. In this case, it's below the line, and so that's where we shade. We label the solution set with the letter S, which stands for solution, and we're all done. Let's take a moment to understand what this solution set represents. And let's do that by taking a look at a few points on the graph. -3, 4, 4, 1, -4, -2, 0, 3. Notice when we look at these points, the y value is always less than or equal to 4. In fact, if you were to write the coordinates of any point in that shaded area, you'd find that the y value is always less than or equal to 4. And that's exactly what this inequality represents, all points whose y-coordinates are less than or equal to 4. Let's take a look at another example. Graph the inequality y is greater than -1. We go to graph the line y equals -1, and we use a dashed line this time because we have a greater than symbol and not a greater than or equal to symbol. With a greater than or a less than, we use a dashed line, which means the points on that line are not a part of the solution set. We then have to decide where to shade. The inequality is y is greater than -1, so we look at the y-axis and identify where the y values are greater than -1. In this case, it's above the line, and so that's the region that we shade. We label our solution set with the letter S, which stands for solution, and we're all done. Now let's understand what this solution set means. Let's take a look at a few points. 4, 1, -2, 0, 5, 5, 1, 1/2, and -4, 3. Notice that in all cases, the y-coordinate is greater than -1, and that's exactly what this shaded area represents. Every point within the shaded region will have a y value that is greater than -1. Notice that no points are on the dashed line because those y values are equal to -1, and that would not satisfy the inequality. Here's an example for you to try. Can you graph the inequality y is less than 3? Please pause the video here and come back when you're ready to check your answer. Let's see how you did. We want to graph the inequality y is less than 3. We begin by graphing the line y equals 3, which is a horizontal line through the y-axis at 3. We use a dashed line because we don't have an equal to in the inequality. We now need to identify where the y values are less than 3. In this case, the y values less than 3 are underneath the line, and so that's the region that I shade. I label the shaded region with the letter S, which stands for solution, and our graph is complete. In our next exercise, we want to graph the inequality x is greater than or equal to 2. We begin by graphing the line x equals 2, which is a vertical line through the x-axis at 2. This is a solid line because our inequality is greater than or equal to, and the equal to tells us we have a solid line. Now we have to decide where to shade. We want x values that are greater than or equal to 2, so we look at the x-axis and find where the x values are greater than or equal to 2. In this case, it's on the right-hand side of the line, and so that's where I shade. As always, I label my solution set with the letter S. Now that we've completed our graph, let's take a moment to understand what the solution set represents. We look at a few points on the graph, 2, 1, 4, 2, 3, -5, 6, 0, and 5, -2. Notice that the x values are all greater than or equal to 2. That's exactly what this inequality represents. The inequality x is greater than or equal to 2 means all of the points on the graph that have x values greater than or equal to 2. In our next exercise, we want to graph the inequality x is less than 3. We begin by graphing the line x equals 3, which is a vertical line through the x-axis at 3. Notice that we do not have a solid line here because we do not have an equal sign in the inequality. A less than is simply a dashed graph. Now we need to identify where we shade. We want to know where on the x-axis are the values less than 3. That would be on the left-hand side of the line, and so that's where we shade. We label the shaded region with the letter S to denote solution set, and we're all done. Remember what the shaded region represents: all of the points that meet the criteria x is less than 3. If you list any point in that shaded region, the x value will be less than 3. Here's a problem for you to try. Can you graph the inequality x is less than or equal to -2? Please pause the video here and come back when you're ready to check your answer. Let's see how you did. We begin by graphing the line x equals -2, which is a vertical line through the x-axis at -2. We use a solid line because our inequality is less than or equal to, and the equal to means that we use the solid line. We then look at the x-axis to determine where the x values are less than or equal to -2. In this case on the left, so that's where we shade. We label our solution set with the letter S for solution, and our graph is complete. This is everything you need to know about graphing inequalities that involve horizontal and vertical lines. You can learn more about linear inequalities in Mr. Dorey's Algebra Handbook, available at www.doreypublications.com.